Hey there, I want to make a video here showing you how to differentiate between the two types of opportunity cost calculations through comparative advantage questions. We've already been through um, some where we do output, so you should be somewhat familiar. I'm going to use the same sort of example here with the deserted island, Robinson and Crusoe, with both um, coconuts and fish. So over here, we'll start over here, output questions. These are probably the most common types of questions that we'll see for questions of this nature, but the input questions over here are sort of flipped, and you have to calculate them in a different way. And so they can trip you up pretty easily, and they can be somewhat confusing. So you have to know how to differentiate between these two when you read a question. So output questions give the quantity of output for a given amount of inputs. Okay, so um, most often in the examples I've been giving of the deserted island, I say in a day's labor, right? So in a day, Robinson can gather 10 coconuts and 5 fish. So that gives you the amount of output for 1 day of labor. Now, there's nothing hard and fast saying it has to be 1 day of labor. It could be a week, could be a month, it could be an hour. But the number that you're given is how much stuff, whatever it is you're talking about, is produced for that given input, right? So Crusoe gathers 15 coconuts or catches 5 fish. Now, that is an output question or phrased in some way or given to you in a table in that sort of manner. Now, an input question can appear to be similar, but it's different, right? It's flipped. So it gives the quantity of inputs needed for a given output. So the way I phrased it in this question is how long does it take to gather one coconut, or how long does it take to catch one fish? So most frequently, input questions will deal with give you a number of a time, right? A certain number of minutes or a certain number of hours to be able to produce one whatever it is you're talking about. In this case, coconuts and fish. Uh, it can also be how many workers does it take to produce a given output, say maybe a car, an automobile, or something larger like that that would take a number of people. Now, number of workers doesn't really make sense in this example, but just so you know, that can be a similar thing. So you're looking for, it gives you an input, right? The quantity of input needed to produce the given input. So you have to be able to identify upfront the way the question is given to you, which one it is, and thereby how you're going to sort of solve it. All right, so I've got a quick example we can go through here. This is an output question. Again, this is the more common type. And any of these types of questions, you may be given the table, you may be told these values in sort of word form, and you have to make the table. But remember cost per gain, right? So this is telling us a number of coconuts, a number of fish, in a given day of labor. This is the maximum they can get. So we know that's an output question. Okay, so remember over here for output, cost over gain. So if we're over here and we're going to fill out our opportunity costs, and then we should be able to answer all these questions down below. All right, so we're going to take, so we gave up 5 fish, we gained 10, so that reduced to 1/2, and that is in terms of fish, right? Remember, we're always in terms of the other good. And let's come over here, we gave up 10 coconuts, 5 fish, so that is 2 coconuts. And remember, these are reciprocals, so that's another way you can sort of check to make sure you're on target. All right, let's come down here. So we gave up 5, we gained 15. That is 1/3 of a fish. Come back over here, 15 over 5. That is 3, and that's in terms of coconuts. Okay, so we should have all our information here. Again, absolute advantage, you don't need to do that, but we did our calculations first. So who produces more coconuts? Okay, well, Crusoe has a bigger number than Robinson, so that would be Crusoe here. Absolute advantage in fish, well, they actually produce the same amount. So no one has an absolute advantage here because they're essentially tied. So there's not always somebody who's better at something than somebody else. So comparative advantage, and remember, comparative advantage, you want the lowest opportunity cost. So we're going to look at coconuts first. Who has the lowest opportunity cost? 1/3 is going to be less than 1/2, right? So Crusoe is going to specialize in coconuts. And go to fish now. Who's got the lower opportunity cost? 2 is less than 3, right? So Robinson's going to specialize in fish because of the lower opportunity cost. So this is essentially asking the same question, just in a different way. Under what terms of trade would they agree? So let's go over here, avoid the fractions there. So one fish, and we're looking for the price of a fish, right? And this is a range. So it's going to be anywhere between those two opportunity costs over here, right? Somewhere in between, they might agree. I don't know, pick one, 2.5. One fish equals 2.5 coconuts. And they might have both agreed to that. So that would be how you figure out the terms of trade. Okay, so that's an output question, how you answer all these types of questions based on that, and especially based on your calculations of the opportunity cost. So we're going to zip ahead and find an input question example. Okay, we're going to keep the same two people, Robinson and Crusoe. We're going to keep it with coconuts and fish, but notice up here. So this is your first clue. It just tells you one coconut and one fish. And then down here in our actual values are times, right? So what this is telling you is how long it takes each individual to produce or gather one coconut or catch one fish. So we know that this is an input question. So I'm going to point you down here because there's the opportunity cost when we try to calculate it is sort of flipped, right? So remember IOU, that is in an input question, the other goes under. And that's exactly sort of opposite of what we did in the previous example, right? An output question. So I'll show you what to mean. We're going to calculate our opportunity cost. So the other, what we mean by the other is the other value over here. So that goes under, and this one goes over. And this is still in terms of the other good. So that's 1/2 fish. Now that makes sense, right, if you think about it, because the tricky part of this, right, and when you go to absolute advantage, smaller numbers are actually better, right? A bigger number means it took me longer, I was less efficient. So it gets sort of flipped. Then we can do the same thing over here. So remember, other goes under. And that is 2 coconuts. Okay, so let's do the same thing down here. Other goes under. That would be 1/3 of a fish. And same thing, other goes under. Okay, so there's our opportunity cost. Now let's go back, absolute advantage in coconuts. Again, remember it's time. So a lower number is actually better. You can produce twice as many if you're half the time. So Crusoe has the absolute advantage in coconuts, and fish, who has the absolute advantage. Crusoe also does because it takes him less time. Okay, now comparative advantage in coconuts. Now, again, it's in terms of fish here. So now we're still looking for the lowest opportunity cost. So 1/3 of a fish is less than 1/2. This unit is not time, so be careful of that, though that lowest one is still better. And again, here, 2 is less than 3, so Robinson has the comparative advantage in fish. So, and this is sort of the same question, and this is actually the same numbers up here, but be sure to do this, right? Because if you don't, then you're going to have these flipped and you'll end up with the wrong opportunity costs on the wrong side. And it's tricky, right? You have to be sure to identify what type of question it is up front. Otherwise, you may not be sure. In this question, the input type question is a little bit less common. but it definitely shows up a fair amount. So you just have to realize and know. Now, once we master that, we can have all kinds of almost an infinite type of questions based on either one of these two formats. So instead of, you can have any two individuals, right, on the deserted island, but then we could expand it. We could be talking about two different countries, essentially any two different countries, and they could be trading any two different products. Now, again, this is a sort of an oversimplified model. In the real world, right, there's many, many more than two products. But again, in the same way we were trying to determine, it's just a model, right? We're trying to simplify the world as much as we can, and then figure out what we can determine based on that. But you could have any type of object, right? Any two goods, right? Cars, automobiles, microchips, lumber, gallons of milk, tons of bananas, barrels of oil, tons of iron ore, right? It doesn't really matter what you're talking about, because you're always going to put the price of the one good in terms of the other good. So don't be fooled by, when they throw different goods at you and different actors, different countries, because they're all sort of the same format of a question. Just figure out as an input or output, and then take the right approach. And these questions should be pretty straightforward for you.